In last video, we discussed about the standard enthalpy of formation. In this video, we are going to discuss standard heat of combustion. The enthalpy change that accompanies a chemical reaction in which 1 mole of compound is completely burnt in excess of oxygen is called standard enthalpy of combustion. Actually, combustion reaction means the burning of that particular compound in excess of oxygen or air. It is called as combustion, and combustion products are always carbon dioxide and water. If there is an organic compound, then organic compound undergoes combustion and we get carbon dioxide and water. Whatever hydrogen present in organic compound, that is converted into water, and carbon content of organic compound, it is converted into carbon dioxide. And here standard heat of combustion means the enthalpy change associated with combustion reaction when 1 mole of particular organic compound is completely burnt in excess of oxygen and forms carbon dioxide and water. This is called as standard heat of combustion. As an example, you consider the combustion of carbon. When 1 mole of carbon is burnt in excess of oxygen to get carbon dioxide, the enthalpy change, it is minus 394 kilojoule. It means for the combustion of 1 mole of carbon, or during combustion of 1 mole of carbon, heat evolved, it is minus 394 kilojoule. Another example, when 1 mole of methane is completely burnt in excess of oxygen to get carbon dioxide and water, the heat evolved, it is minus 88 kilojoule, and therefore standard heat of combustion of methane, 1 mole of methane, is minus 88 kilojoule. Similarly, when 1 mole of ethane is burnt in excess of oxygen to get carbon dioxide and water, heat evolved or enthalpy of combustion for this reaction is minus 1300 kilojoule. When you look at these three reactions, combustion reactions, so compound involved in combustion, it should be always 1 mole. Combustion products may be having different number of moles, but the compound involved to undergo combustion, it should be 1 mole, because in definition it is mentioned that enthalpy change accompanying a combustion reaction when 1 mole of compound is completely burnt in excess of oxygen. So that compound should be 1 mole. And these are the enthalpies of combustion for carbon, methane and ethane. The most important thing is standard heat of combustion, it is always negative. It means heat is evolved. During combustion process, heat is evolved. This is very important. Now next term is bond energy or bond enthalpy. Now at the time of chemical reaction, you know that the reactants are converted into products, and in reactants some bonds are broken and in products some bonds are formed. And the bond enthalpy, it is nothing but the average amount of energy required to break all the covalent bonds in 1 mole of substance to form gaseous atoms or radicals is called bond energy. You always keep in mind, to break bond energy is required, and at the time of formation of chemical bond, energy is evolved. So here in the definition of bond energy or bond enthalpy, there is a wording like amount of energy required. So bond energy is positive, it is always positive. Energy is required to break the bond, and the definition once again, I am repeating the definition. The average amount of energy required to break all the covalent bonds in 1 mole of substance to form gaseous atoms or radicals, it is called as bond energy. Actually, after breaking covalent bond between two atoms, there is a formation of either free atoms or radicals, maybe free radicals, ions, or like that. Okay, so it is always positive. Bond enthalpy is always positive. That is, energy is needed to break bond between two atoms. The bond enthalpy or bond energy, it is measured in kilocalorie per mole or kilojoule per mole. And bond enthalpy, it is the measure of strength of bond. Greater the bond enthalpy, greater is the strength of bond, or stronger the bond. In other words, we say that stronger the bond, greater is the energy required to break that particular bond, and hence greater is the bond energy. And therefore bond energy, it is a measure of strength of bond. For diatomic molecules like hydrogen, that is H2, chlorine, that is Cl2, the bond enthalpy or bond energy, it is equal to enthalpy of atomization. And enthalpy of atomization, it is amount of energy required to break the chemical bond between two atoms in diatomic molecule. It is to break bond between two atoms to form the atoms or radicals. This is the atomization. When particular molecule is converted into corresponding atoms, whatever enthalpy is changes there, that is the enthalpy of atomization. Already we discussed this term in earlier videos. But for diatomic molecule, bond energy is exactly equal to enthalpy of atomization. But for polyatomic molecules like water, it contains 3 atoms, or carbon dioxide or methane, like that. For polyatomic molecules, the bond energy and enthalpy of atomization, they are different. And here for polyatomic molecules, the average bond enthalpy is considered, or it is obtained. We will take example. First of all, you consider the diatomic molecule like hydrogen. When hydrogen gas, actually hydrogen is a diatomic molecule. When covalent bond between two hydrogen atoms is broken, there is a formation of hydrogen atoms, and the energy required to break bond between two hydrogen atoms in 1 mole of hydrogen gas, it is 436.4 kilojoule per mole, and this is the bond enthalpy for hydrogen. Similarly, for chlorine, to break bond between two chlorine atoms in 1 mole of chlorine gas, energy required is 242.7 kilojoule, and this is the bond enthalpy of chlorine. This is also nothing but the enthalpy of atomization of chlorine as well as for hydrogen. Now another diatomic molecule, that is hydrogen chloride. To break bond between hydrogen and chlorine atom in hydrogen chloride, energy required equal to 431.9 kilojoule, and this is the bond energy for HCl. Now consider the polyatomic molecule like water. In water there are two OH bonds, and breaking of bond between oxygen and hydrogen takes place in 2 steps. In first step, out of 2 OH bond, 1 OH bond is broken, and suppose H2O vapor, it is converted into OH plus H. Out of 2 OH bond, 1 OH bond is broken here, and energy required to break first OH bond, it is 499 kilojoule. Now again, water is not completely converted into atoms, or all the covalent bonds are not broken. One covalent bond still exists between oxygen and hydrogen over here. In second step, there is a breaking of covalent bond between this oxygen and hydrogen. This is the second covalent bond in water. Now there is a formation of oxygen and hydrogen. Second time, to break OH bond, energy required is 428 kilojoule. For breaking of first OH bond, there is a requirement of 499 kilojoule energy, and to break second OH bond, there is a requirement of 428 kilojoule energy. Now, less energy is required to break second bond. Actually, OH species, it is less stable as compared to water, and to break bond from the stable molecule, more energy is required. So OH is comparatively less stable than water, and therefore for second step, comparatively less energy is required. Now the average bond enthalpy or average bond energy is the mean of these two values. Now here OH, these are the common, they gets cancelled, and when we take sum of these two equations, then it will be H2O gives O plus 2H. Now here in this equation, water is completely converted into, or there is a atomization, or from water all the bonds are broken and there is a formation of atoms, and the enthalpy change, actually we added these two equations, and therefore when we add these two enthalpy change values, then it will be 927 kilojoule. Actually this equation first and equation 2, these two are added. Similarly these two values are also added and we get 927 kilojoule. But average bond enthalpy for OH bond, it is equal to 927 upon 2, that is equal to 463.5 kilojoule. Why divided by 2? Because to break all the bonds there are two steps, or bond breaking process takes place in two steps, and therefore divided by 2, and it is equal to 463.5 kilojoule per mole, and this is the average bond enthalpy for water. So it is average bond enthalpy for OH bond, it is 463.4 kilojoule per mole. Now from average bond enthalpy, we can find out the heat of formation of the reaction. The standard enthalpy of formation, it is calculated from bond energy of reactants and products, and the formula is enthalpy of formation for the reaction, it is equal to sum of bond enthalpies of reactants minus sum of bond enthalpies of products. Consider the example of formation of hydrogen iodide gas from gaseous hydrogen and gaseous iodine. When hydrogen gas is mixed with iodine vapors, there is a formation of hydrogen iodide in gaseous phase. So for this reaction, enthalpy of formation, standard enthalpy of formation, it is equal to standard enthalpy or standard bond enthalpy of hydrogen plus standard bond enthalpy of iodine minus the standard bond enthalpy of hydrogen iodide. So here this first term, it is the sum of bond enthalpies of reactants, and this second term or right side term, it is the sum of bond enthalpies of products, and therefore the heat of formation of a reaction, it is equal to sum of bond enthalpies of reactants minus sum of bond enthalpies of products. And from this equation we can, or from this relation we can find out the enthalpy of formation of the particular reaction. In next video we will solve some examples on this point, that is calculation of heat of formation.